Healthy soils are fundamental for healthy farming systems. There are many ways of checking the health of your soils. Sometimes it's just as simple as knowing what to look for as you walk across your paddocks. This is the final in a series of 3 videos that condense years of agronomic experience down into some easy to use strategies.
It will equip you to interpret some of the common things you see in pasture paddock soils so you can begin diagnosing what the underlying problem might be and how to go about finding a management strategy to remedy it. Sometimes after rain, you may see milky tea-coloured water pooling on the soil surface. They will often be sticky, clumping on your boots or tyres as you travel through the paddock. These same soils may have been hard and crusty when dry, and the rain has greatly altered their appearance.
There are 2 possible causes of this. Firstly, the soil might be dispersive. This means that when the soil becomes wet, the individual clay particles separate from one another. This is caused by excessive sodium and insufficient organic matter to hold the soil together. The other possible explanation is the soil has slaked. This is when soil break apart when it is wet due to low organic matter.
To test this, the simplest method is an aggregate stability test. This involves placing a small soil crumb around 5 to 10 millimeters into a dish with distilled or rainwater and observing their reaction over time. After 2 hours' time, the soil has been forming a milky cloud around the aggregate. By 24 hours' time, only sand particles remain and all the clay has formed a milky cloud, which means it is fully dispersed into the solution. It's common for subsoil layers to do this and block pore spaces and reduce infiltration, but it's hard to treat at depth. When the topsoil disperses, it can cause surface sealing and stop plant germination. This sort of soil is also prone to erosion. Your soil test might provide a hint that the soil could be dispersive. If the sodium level is over 15% and organic matter is low, the soil is likely to be dispersive. Excess sodium and other salts in water tables within 1 to 2 meters of the soil surface causes a different problem called salinity. They will grow different plant species which are tolerant of salt, or in more severe cases, contain bare areas and salt crystals that can be seen on the surface. A soil test in the affected area with reference to EC or electrical conductivity can help confirm salinity. How bad the salt level measured by EC will impact on plant growth is dependent on the plant and soil texture. Clays are often more affected because they have fine pores that act like a wick. As water evaporates from the surface, moisture-containing salts is pulled up from the water tables at depths of up to 2 meters. Late spring is a good time to observe salinity because the area will have poor growth and the different plant species which grow in them are flowering. Species like sea barleygrass, buckshorn plantain, which goes red with salt stress, and yellow water buttons. Another common sight on the soil surface is disturbance with lots of soil crumbs on the surface. You will often see this in moist soils in winter and spring. These are caused by earthworms as they move through the soil and excrete waste, otherwise known as casts. Having earthworms is a great indicator of soil health, but you generally only find them in moist soils. Earthworm activity can look deceptively similar to black-headed cockchafer activity. The difference is that black-headed cockchafers will form mounded tunnels, whereas the earthworm casts are more distinct crumbs. If in doubt, grab a shovel and have a dig to check for earthworms or cockchafers. Root assessments are another helpful indicator of soil health. When legumes are dug up carefully, you should see nodules on the roots. A healthy root system has a lot of pink nodules. If there are few nodules or they are white, it could indicate a number of things about the soil health. It could be soil acidity and high soil aluminium levels. It could be insufficient soil rhizobia as a result of long-term cropping. It could be residual herbicide damage, or a nutrient deficiency or molybdenum or sulfur. It is helpful to have an idea of the cropping history of the paddock as soil rhizobia numbers decline after 3 years without a host. To test if it is a nutrient deficiency, you could take a tissue test of the subclover leaves with reference to molybdenum. You could also try putting out test strips of molybdenum and sulfur fertilizers. See the fact sheet in the information section below for more details on assessing legume nodulation.
We hope that these simple observations that you can make as you move across a paddock will help you better understand your soil and assess its condition.